Let's go from multiplication to addition. We do these at the grocery store, for instance. In fact, let's pretend like you've got a bunch of items that you need to ring up, and I'll try and be almost a human cashier here and figure out the total at the end. So what's the first item?
$4.86.
Well, that's it. Okay, $4.86. Okay, and then the next item?
$3.55.
$3.55. Okay, and then the next item?
$3.28.
And then the next item?
$2.96.
Okay, that should be $14.61. Is that our total? Great. And in fact, if you paid that with a $20 bill, your change would be $5.39. Once we learn how to count, the first rules of arithmetic that we learn are addition and subtraction. And in order to do multiplication and division, it's crucial that we be able to add and subtract numbers efficiently. In Lecture 1, we did some very easy addition problems and started the good habit of working from left to right. In this lecture, we'll continue to work from left to right, starting with simple problems and working up to more complicated ones. When doing mental addition, we work one digit at a time, so let's begin with the addition of a one-digit number. What is 52 plus 4? Now in your head, you should think 2 plus 4 is 6, so 52 plus 4 is 56. How about 56 plus 7? Now in my head, I recognize that 6 plus 7 is greater than 10. So since I'm adding something to 50, I know the answer will be 60-something. And since 6 plus 7 is 13, and that ends in 3, the answer is 63. Here, let's try 76 plus 6. Since 6 plus 6 is bigger than 10, the answer will be 80-something. 80 what? Well, 6 plus 6 is 12, which ends in 2, so the answer is 82. Okay, now let's start adding two-digit numbers. The easiest situation is when one of the numbers ends in 0. Let's first do 60 plus 27. Now, since 60 plus 20 is 80, 60 plus 27 is 87. The 7 just comes along for the ride. Here, now you try 81 plus 90. Since 80 plus 90 is 170, 81 plus 90 is 171. If we want to add any two-digit numbers, we first add the tens digit, then add the ones digit. So for example, the problem 62 plus 24. We first add the 20, then add the 4. Okay, so 62 plus 24. After adding 20, the problem simplifies to, let's see, 62 plus 20 is 82, so we have a new problem, 82 plus 4. And 82 plus 4 is 86, and that's the answer. Here, let's try 73 plus 16. First, we're going to add the 10, then add 6. 73 plus 16. 73 plus 10 is 83, so we have a new problem, 83 plus 6, which is simply 89. The next few problems are just a little bit trickier because some carrying occurs. Let's do 23 plus 58. First we add 50, then we add 8. 23 plus 50 is 73. Then we add 8. 73 plus 8, though it has a carry, doesn't bother us. That's 81. All right, let's try 48 plus 37. What's our strategy? First add 30, then add 7. 48 plus 30 is 78. Then add 7, giving us 85. All right, here's a bigger one. Let's try 84 plus 87. Okay, so we're going to add 80, then add 7. Now 84 plus 80, see 80 plus 80 is 160, so 84 plus 80 is 164. Plus 7, go ahead and say that 100 if you want. 100, 64 plus 7 is 71. There's the answer, 171. With just a little bit of practice, you can add any 2-digit numbers in just a few seconds, but it certainly requires practice. Here are some problems that you may want to try on your own before moving on. I recommend pausing this course for just a minute and trying these problems. And here are their solutions. Okay, now let's move on to adding 3-digit numbers, which is a lot harder on your memory. Of course, the easiest 3-digit number addition problems are when both numbers are multiples of 100, like 500 plus 200 is 700, or 700 plus 600 is 1300. The next easiest situation is when one of them is a multiple of 100. You try 400 plus 567. 400 plus 500 is 900, and the 67 comes along for the ride, so the answer is 967. Let's do 235 plus 800. Now 200 plus 800 is 1,000, 1,000. So 235 plus 800 is 1,035. The next easiest problems are when both numbers are multiples of 10. For example, 450 plus 320. Here our strategy is to first add 300, then add 20. 450 plus 320, this becomes, after adding 300, 750 plus 20. 750 plus 20 is 770, 770, that's your answer. We often see round numbers like this when we're counting calories. For example, if a fast food restaurant sells a hamburger with 410 calories and a bag of French fries with 360 calories, then the total number of calories would be 410 plus 360. We're going to add 300, then add 60. 410 plus 300 becomes 710 plus 60. You could pause. You have a simpler problem now. 710 plus 60 is 770. When you throw in a 560 calorie milkshake, then how many calories would you have? Well, 770 plus 560, we're going to first add 500, then add 60. 770 plus 500 is 1,270 plus 60. 1,270 plus 60, that's going to be 1,300 and something. 70 plus 60 ends in 30, so it's 1,330. Now, in order to add any two 3-digit numbers together, it's a simple 3-step process. First, add the hundreds digits, then add the rest, the tens and the ones digit. Let's try the addition problem 314 plus 159. Say it out loud. 314 plus 159. Our strategy is to add 100, then 59. So 314 plus 100 is 414 plus 59. Again, you could pause, take a break. You have a simpler problem. 414 plus 59. So next, if you want to, you could even say the 400. At this point, you know enough about your answer to say 400 and focus on 14 plus 59. When we do that, 14 plus 50 is 64, plus 9 is 473, and now you've said your answer, 473. Okay, the next problem is about as hard as it gets. Let's try 766 plus 489. Even remembering the problem takes some work, right? 766 plus 489. First we add 400, then we'll add 89. 766 plus 400 is 1166. And now you add 89. Now I know enough about my answer to say 1200, and I'll focus on 66 plus 89. So first we'll add 80. 66 plus 80 is 146. Then I'll add the 9 to get 155. So I know the answer ends in 55, and there's the answer, 1255. Now that problem was probably hard for you because you need almost all of your memory just to hold on to the original problem. And each addition step that we did involved a carry. But as you take each step, the problem becomes simpler, and you can start to say your answer along the way. Now, as it turns out, there's another way to solve the last problem that you might find easier. To do 766 plus 489, notice that 489 is 500 minus 11. So if you want, you can do 766 plus 489 by adding 500, then subtracting 11. And that's easier. 766 plus 500 is 1266. And now what do? Subtract 11. 66 minus 11 is 55, so there's your answer, 1255. The lesson here is that hard addition problems, those involving lots of carries, can usually be turned into easy subtraction problems that don't involve any borrowing. So let's turn our attention to subtraction. How are we going to do mental subtraction? Well, just like with mental addition, we do it one digit at a time from left to right. We'll start with two-digit numbers. Let's look at the problem 93 minus 41. All right, we're going to first subtract 40, then subtract 1. 93 minus 40 is 53. So you have a new, simpler problem, 53 minus 1, which is 52. Now that problem was easy because of the ones digit. The 3 is bigger than the 1, and that made things easier. Let's try 74 minus 29. That'll be a little trickier. Now there are two ways you can do this. In the first way, you subtract 20, then subtract 9. So the problem becomes 74 minus 29. I subtract 20, and I have 54 minus 9. 54 minus 9, it's going to be 40-something. 40 what? Well, we know that 14 minus 9 is 5, so it's got to be 45. But I prefer to do this problem a different way. Let's treat 29 as 30 minus 1. So to subtract 29, we're going to first subtract 30, then add back 1. Okay, 74 minus 29. We do 74 minus 30 to get 44, then add back 1 to get 45. Did you find that second method easier? You try it this time with 82 minus 48. Okay, so what are we going to do? To subtract 48, we're going to subtract 50, then add back 2. 82 minus 50 is 32. When we add back 2, we get 34. In the addition section, we saw that a complicated addition problem, one that had lots of carries, can be converted into an easy subtraction problem with no borrowing. Here we see that a subtraction problem that would normally involve borrowing can be turned into an easy addition problem with no carrying. The advantages are even clearer as the numbers get larger. Here, you try the problem 121 minus 57. What's our strategy? We're going to first, to subtract 57, let's subtract 60, then add back 3. Okay, so we start by doing 121 minus 60. 121 minus 60. Well, 120 minus 60 is 60. When we add back 1, when we include the 1, we have 61. Okay, so 121 minus 60 is 61. Add back 3 to get 64, and that's the answer. Now let's subtract 3-digit numbers. If you're lucky, every digit in the first number is at least as big as the corresponding digit of the second number. That happens only if you're lucky. But when that happens, you'll subtract the hundreds, then the tens, then the ones. For example, let's do the problem 846 minus 225. We're going to first subtract 200, then subtract 25. 846 minus 225. The hardest part about doing this problem is keeping it in your memory. Now, I do this by saying the problem, at least in my head, 846 minus 225. And as I say this, I'll focus on the hundreds digit, 846 minus 225. 8 minus 2 is 6, so 846 minus 225 becomes 646 minus 25. Take a pause, take a break. This is a simpler problem, 646 minus 25, and that's easier to remember. You can even say 600 if you want. Get that out of your memory. And now we have 46 minus 25 to do. So first we subtract 20, then we'll subtract 5. 46 minus 20 is 26, minus 5 is 21. Go ahead and say it, 21. You've now said your answer, 621. The bad news is that most 3-digit subtraction problems require some sort of borrowing. But the good news is that they can be turned into easy addition problems. Let's start with a very easy one. It would be hard for you to do it on paper, but in your head it's really easy. Let's do 835 minus 497. Again, not fun to do on paper, but it is fun in your head, because 497 is simply 500 minus 3. So to subtract 497, we'll subtract 500, then add back 3. Okay, so 835 minus 500 is 335, and now we add back 3 to get 338. Here, let's change the problem slightly to 835 minus 417. New problem here. 835 minus 417. First, we're going to subtract 400. Okay, so 835 minus 417 becomes 435 minus 17. You could even say the 400 at this point. Say it. 400. Okay, now we'll do 35 minus 17. How do we do that? Well, we'll subtract 17 by subtracting 20 and adding back 3. 35 minus 20 is 15. When you add back 3, you have 18, and there's your answer, 418. Okay, raising the stakes a little, what if the problem were 835 minus 467? Before answering this, let's do a very important warm-up exercise. How far are these numbers from 100? Okay, 75, 49, 67, 33, and 80. How far are they from 100? Here are the answers. We say that the complement of 75 is 25 because 75 plus 25 is 100. Likewise, the complement of 49 is 51 because 49 plus 51 is 100, and so on. Now, how do you find the complement? The pattern is very simple, and we do it from left to right. The first digits add up to 9, and the last digits add up to 10. So for the complement of 75, notice 7 plus 2 is 9, and 5 plus 5 is 10. Look at the number 49. How do you find its complement? Well, 4 plus 5 is 9, and 9 plus 1 is 10. So the complement of 49 is 51. Right? 67, how would you find its complement? Well, what do you have to add to 6 to get 9? 3. What do you have to add to 7 to get 10? 3. So the complement of 67 is 33. And similarly, the complement of 33 would be 67. Now, wait, I see an exception here. Look at the last problem, 80 plus 20. If the number ends in 0, like 80, then the complement will also end in 0. And the first digits, instead of adding up to 9, they're going to add up to 10. So the complement of 80 is 20, but we knew that already, right? How far is 80 from 100? It's 20. Okay, now let's go back to our original problem, 835 minus 467. Since 67 is bigger than 35, I'm going to do this problem by subtracting 500, then adding back something. Okay, so here we do. 835 minus 500 is 335 plus something. Now, what is that something? Well, how far is 467 from 500? Here's the same question. How far is 67 from 100? We know the complement of 67 is 33. So 335 plus 33, right, is, from left to right, 368. Okay, here's another problem. Let's do 621 minus 274. Okay, how are we going to subtract 274? We'll subtract 300 and add back what? The complement of 74, which is 26. So when I subtract 300, 621 minus 300 is 321. When you add back 26, you get 321 plus 26 from left to right is 347. I personally think that it's easier to do this problem mentally using complements than by the pencil and paper method. We are turning a hard subtraction problem into an easy addition problem. Here, let's do one more. Consider the problem 729 minus 256. What's our strategy? We'll subtract 300 and add back the complement of 56, 44. Okay, so 729, I'm going to subtract 300, then add back 44. 729 minus 300 is 429. Now add 44. Take a breath. Take a break. 429 plus 44. You have a new problem. It's a simpler problem. 429 plus 44, let's see, is 469 plus 4 is 473. Okay, let's do one more just for fun. Let's do 1, 2, 3, 4 minus 5, 6, 7. Okay? How do we do that? We're going to subtract 600 and add back the complement of 67, 33. So 1,234 minus 600 is 634. Add 33 from left to right, and we get 667. Look what we did. We took what would have been an ugly subtraction problem and turned it into an easy addition problem. Sometimes it's convenient to know your three-digit complements. How far are these three-digit numbers from 1,000? 675, 849, 777, 223, and 670. How far are they from 1,000? Check it out. 325, 151, 223, 777, and 330. Do you see the pattern? The complement of 675 is 325. And if you look at the digits, the digits on the left, 6 plus 3 is 9. Then the middle digits, 7 plus 2 is 9. And the digits on the right, 5 plus 5 is 10. They add up to 9, then 10. This makes sense, by the way, because if you were to actually do that addition problem on paper from right to left, like you've usually done, 675 plus 325, how would that go? You'd start on the right with 5 plus 5 is 10, which would put down the 0, carry the 1. Then that 1, you'd add that to 7 plus 2, which is 9. 1 plus 9 is 10. You'd put down a 0, carry the 1. Right? Then you'd have another 1 to add to 6 plus 3. 6 plus 3 is 9. Add that to 1 is another 10, and that's how you get 1,000. So for that reason, if we sum the columns of the other 3-digit numbers, we'll have the same pattern, right? 9, 9, 10. 9, 9, 10. 9, 9, 10. But wait, there's another exception. If the original number ends in 0, then so will its complement. So with a problem like 670, the complement will also end in 0. And that's going to be preceded by the complement of 67. And the complement of 67 is 33, so that gives us a complement of 330. You will use 3-digit complements all the time when making change. For example, if an item cost $6.75 and you pay with a $10 bill, then the amount of change you get back will be the complement of $6.75, namely $3.25, $3.25. If the item costs, let's say, $8.49, then change from a 10 would be what? What's the complement of 849? Let's see, they have to add up to 9, 9, 10, so we get 151. $1.51 would be your change. The same strategy works for change from $100. What's the change for $23.58? Well, here we have the numbers have to add up to 9, 9, 9, and 10. For the complement of 2358, that's going to be 7642. We did that left to right, 9, 9, 9, 10. Adds up to 7642. That would be your change. Now, in practice, when I hear $23.58, what actually goes through my mind is I think the dollars add to 99 and the cents will add to 100. So if you had the problem $23.58, you think what adds to 99? 76. What do I have to add to 58 to get 100? 42 to get 76.42. When making change from $20, the idea is essentially the same, but with a tiny change, if you will. Here, when making change from a 20, the dollars add to 19 and the cents add to 100, right? So for example, if an item cost $13.57 and you pay with a $20 bill, what would your change be? Okay, the dollars add to 19 and the cents add to 100. So $13.57. If the dollars add to 19, that gives you $6. And the cents add to 100. What's the complement of 57? It's 43. So there's your answer, $6.43. Okay, your turn. If the bill came to $7.56, what's the change from a 20? What do we get for $7.56? The dollars add to 19, so it's $12 and complement of 56, 44 cents. The mathematics of making change is very handy, but I hope more importantly that it has started to change the way you think about mathematics. In this lecture, I've shown you nearly everything I know about mental addition and subtraction. Let me sum up the main ideas for you, which are pretty simple. We work from left to right, go one digit at a time, and look for opportunities to use complements that turn hard addition problems into easy subtraction problems, and vice versa. Now, we did problems as large as adding and subtracting three-digit numbers together. You might wonder, why didn't we go higher? When the problems get very large, we usually resort to mental estimation. And besides, to add a pair of four-digit numbers, it can be a challenge just to remember the problem. The human memory can only hold on to about 7 to 10 digits without resorting to special memory tricks that I'll cover later. Of course, some four-digit numbers are very easy to add, especially when they have lots of zeros. You can do 1,234 plus 5,000, right, to get 6,234. Since there are not really 8 digits to remember, it's really more like 5 digits to remember. It's also not hard to add a 4-digit number to a 3-digit number when they only overlap in one place. For example, 2,700 plus 180 is, listen to the numbers, 2,880. We see this all the time when we do multiplication problems, which is the topic of our next lecture. I recommend taking a little time now to practice your addition and subtraction, and then you should be prepared for the next lecture to go forth and multiply.